Good morning to all of you. Hello? Hello? Hello?
Good morning, ma'am.
Good morning, ma'am.
Am I audible? Hello?
Yes, ma'am.
Okay. Then, uh, in the previous class, we have discussed about continuity and definition of continuity is already given and some examples already discussed in the previous class. And today I want to discuss some problems related with continuity. Okay, and in the previous class we have discussed some simple problems. So, can you tell me the definition of continuity? I have already given you. Can you tell me the definition of continuity? Hello? Hello? Anyone? Can you tell me the definition of continuity? So, suppose we consider a function f and we have to check the continuity at suppose x equals to 3. Okay, then f is said to be continuous at the particular point c if, according to the definition, it is what? Limit x tends to c, f of x equals to f of c. Okay, and limit x tends to c, f of x. This indicates what? This indicates the equality of left hand limit and right hand limit. Okay, limit x tends to c minus f of x. This indicates what? Left hand limit of f of x at the point c. Okay, and is equals to what? Limit x tends to c plus f of x. This indicates what? This indicates the right hand limit of the function f at the point c. If left hand limit equals to right hand limit equal the functional value, okay, functional value, that is f of c. If all are equal, then we say that the function is continuous at x equals to c. Okay, and so in the definition, it is given like as limit x tends to c, f of x equals to f of c. Okay, and this is the definition of the continuity at a particular point x equals to c. Okay, and this definition is already given, and now see this example. Here we have to take the continuity of f, and f is given like as this one, modulus function x. F of x equals to modulus function x, and we have to take the continuity at x equals to 0. At x equals to 0, and to set the continuity of f at x equals to 0, first you have to define this function. F of x equals to what? This one is the modulus function x. Then mod of x can be defined is minus x if x less than 0 and x if x greater equals to 0. This is the definition of modulus function, and this is already given when we discuss about function. Okay, and definition of modulus function is this one: f of x equals to minus x if x less than 0 and positive, x is positive if x greater equals to 0. Okay, here we have to set the continuity at x equals to 0, so we have to find left hand limit at x equals to 0. So you have to find limit x tends to 0 minus f of x. Okay, and see that according to the definition, if x less than 0, the value is what? Minus x. Okay, and so when we take limit x tends to 0 minus, that is this left hand limit, then function value is what? Minus x. Limit x tends to 0 minus x. And here, see that limit x tends to 0 minus x. This will be what? Is 0. And similarly, you have to find the right hand limit. So, for the right hand limit, you have to find limit x tends to 0 plus f of x. Okay, and see that when x tends to 0 plus, that means x approaches to 0 from the right side. Okay, then their functional value is what? See the definition. Functional value is what? Positive x. That is, this one is x. Limit x tends to 0 plus x. So value is what? 0. And see that here left hand limit and right hand limit both are equal. Now you have to find f of 0. Now can you tell me f of 0 is what? Here f of 0 will be what? See the definition. F of x equals to x if x greater or equals to 0. If suppose x equals to 0, it is x. If x equals to 0, it is x. That is what? If x equals to 0, we have to find f of 0. It is f of 0 will be what? 0. Okay? Is it clear? Hello? Hello? Is it clear? So see that here left hand limit and right hand limit both are equal, that are 0, and the functional value is what? F of 0. F of 0 is what? Is also 0. So we can say that this function is continuous at x equals to 0. Okay? Is it clear? Hello? Hello? Is it clear?
Hello.
Yeah, is it clear?
Yes, ma'am.
Okay then.
Yes, ma'am.
Okay then, next go to the next example. Here see that f of x equals to this one. Function is defined in this way. It means when x does not equals to 0, it is x cube plus 3, and when x equals to 0, f of x is what? 1. Okay, the function is defined in this way. F of x equals to x cube plus 3 if x does not equals to 0, and f of x is 1 when x equals to 0. Okay, now you have to take the continuity at x equals to 0. At x equals to 0, we check the continuity. Okay, and can you tell me here, because we are going to check the continuity at x equals to 0. Okay, then in the first step, what we find? Can you tell me? Because we are going to check the continuity at x equals to 0. Isn't it? Hello? Yeah, Yasmin, tell me.
Yes, ma'am.
Then in the first step, what we find? Can you tell me? Because we have to check the continuity at x equals to what?
Hello.
Yeah, we want to check the continuity at x equals to what? Hello? Hello? We want to check the continuity.
Hello, ma'am.
Yeah, can you tell me for this problem in the first step what we find?
If x is not equal to x is
Yeah, tell me. Because we have to check the continuity at the point what? First, see the problem. We are going to check the continuity at x equals to 0, isn't it? We are going to check the continuity at x equals to 0. Okay, so first you have to find the left hand limit. Left hand limit means what? Limit x tends to 0 minus. Okay, you have to find the left hand limit. That is what? Limit x tends to 0 minus f of x, isn't it? So see that here, according to the definition of the function, it is given as f of x equals to x cube plus 3 if x does not equals to 0. So when we put limit x tends to 0 minus, then f of x is what? Limit x tends to 0 minus f of x. For the left hand limit, the functional value is what?
Then 3.
No. First, in the place of f of x, what we write?
Then limit x tends to 0,
Yeah,
0 minus,
yeah,
and bracket inside bracket
yeah.
0 0 cube plus 3.
X cube plus 3. Just tell me the functional value. Functional value. Because here function is what? F of x is x cube plus 3 if x does not equals to 0. Is not it? So if we write limit x tends to 0 minus, then in the place of f of x, we write just x cube plus 3. Clear? Is it clear? So here we write, see this one, limit x tends to 0 minus f of x. So x cube plus 3. So it will give what? 0 cube, 0 cube plus 3. So value will be what? 3. Similarly, try to find the right hand limit. Okay, right hand limit means what? Limit x tends to 0 plus f of x. Limit x tends to 0 plus f of x. In this case also, in the place of f of x, we write x cube plus 3 because the function is given in this way. When x does not equals to 0, the value is what? X cube plus 3. Okay? When x does not equals to 0, then value is what? X cube plus 3. So for this part, when we write x tends to 0 plus f of x is what? X cube plus 3. Okay? Is it clear? For the right hand limit also, we write it is x cube plus 3, and the fourth and the left hand limit also we write f of x equals to x cube plus 3 only because of f of x is what? X cube plus 3 if x does not equals to 0. Okay? So left hand limit will be 3 and right hand limit is also 3. Okay? Because if we put this is 0 cube plus 3, the value will be 3, and for the right hand limit, limit x tends to 0 plus f of x equals to x cube plus 3. Then if we put the value of limit, that means value of x, then this gives what? 0 cube plus 3. So it will be what? 3. Okay? And now see that here left hand limit and right hand limit both are equal. Now we have to find f of 0 because we are set the continuity at x equals to 0. So we have to find the value of f of 0. Okay? So now can you tell me f of 0 is what? Now tell me f of 0 will be what?
F of 0 will be 3.
F of 0, only f of 0. Functional value when x equals to 0, f of x is what? See the definition. Because we have to set the continuity at x equals to 0. So first we find left hand limit and right hand limit. Already we have find the left hand limit and right hand limit. Now we have to find the functional value at that particular point. Okay. So here we set the continuity at x equals to 0. So we have to find the value of f of 0. Now can we tell me the value of f of 0? F of 0 will be what? F of 0 will be what?
0.
See the definition of the function. How can we tell f of 0 equals to 0? If x equals to 0, it is what? I am not saying about limit x tends to 0. I just say about f of 0. Okay? I am not asking about limit x tends to 0. 0 minus or x tends to 0 plus. I just tell about f of 0. See the definition of the function. If x equals to 0, it will be what? The value is, see the function. If x equals to 0, the value is what? Yeah, tell me, if x equals to 0, f of x is what? Value is what? 1. See the definition. If x equals to 0, f of x is what? 1. Just see the definition. When x tends to 0, that means x tends to 0 means what? X does not equals to 0. So for that case, we write f of x equals to x cube plus 3 because x tends to 0 means what? It does not equals to 0. X does not equals to 0. Is not it? Limit x tends to 0 minus, limit x tends to 0 plus. This means what? X does not equals to 0. Okay? So for that we write f of x equals to x cube plus 3. But when we write x equals to 0, then f of x is what? F of x is 1. Is that it? Is it clear? Are you understand? When we write limit x tends to 0, then functional value is what? X cube plus 3. But when we write x equals to 0, when we write x tends to 0, that means what? X does not equals to 0. X tends to 0 means what? X does not equals to 0. So for that case, we write f of x equals to x cube plus 3. But when we consider x equals to 0, then f of x is what? 1. Okay, just see the definition of the function. After that you can say. Okay, so here if x equals to 0, then f of x is what? 1. Okay, now tell me here limit x tends to 0, f of x equals to f of 0. Is it true for this function? Because here f of 0 is what? F of 0 is 1. Is not it? F of 0 is 1, but limit x tends to 0, f of x is what? 3. Is not it? Limit x tends to 0, f of x equals to 3, and f of 0 is what? Is 1. Now, is it equal?
No, ma'am.
Limit x tends to 0, f of x equals to f of 0. Is it true for this function?
Not true. False.
Because f of 0 is what? 1 and limit x tends to 0, f of x is 3. Both are not equal. Is not it? Both are not equal means what? The function is not continuous at x equals to 0. So x equals to 0 is what? The point of discontinuity. If the function is not continuous, what we say it is discontinuous. Is not it? Here, a limit x tends to 0, f of x is 3 and f of 0 is what? 1 because limit x tends to 0, f of x does not equals to f of c. Then what we say? We say that the f of x is not continuous at x equals to 0. Okay? Is it clear now?
Yes,
Is it clear?
yes, ma'am.
Okay then, and write some note like as the constant function is continuous everywhere. Write like a note. Constant function means what? F of x equals to k. It has already discussed. When we discuss about function, then in that class I have already told about some special type of real valued function. Some special type of real valued function that these are what? Identity function, constant function, polynomial function, rational function, signum function, modulus function and greatest integer function. I have already given you the definition of all that functions. Okay, and the graph of that functions are already discussed. Okay, here just write a note. The constant function is continuous everywhere. Next, write number 2. Identity function is continuous everywhere. First, write constant function is continuous everywhere. Number 2, write as a polynomial function. Identity function is continuous everywhere. When we see the graph, then you can easily understand that functions are continuous. Next, number 3, write as polynomial function is continuous everywhere. Okay, and in the next example, it is given as f of x equals to k. That is what f of x is continuous, and this f of x is constant function, and this is continuous. Okay, proof is not necessary. Just write as constant function is continuous everywhere. And next, write as identity function is continuous everywhere. Number 3, write as polynomial function is continuous everywhere. Okay. Okay. Have you write?
Yes, ma'am.
Okay then.
Yes.
And write next polynomial function is continuous everywhere. Next, see this example. Is the function f of x is mod of x? This is modulus function. Is it continuous? It has already proved. At x equals to 0, f of x is continuous. We have already checked it. Okay, the function defined as f of x equals to mod of x. This function is continuous at x equals to 0. It has already said. Now we take a point C. Suppose C, and we have to see any real number, and we have to take the continuity at x equals to C, because here we are not given a particular point to take the continuity. We are asking that f of x equals to mod x, is it continuous? Is it a continuous function? Okay, but in the previous example, we are given that take the continuity of f of x equals to mod of x at x equals to 0. But in this problem, we are not given a particular point. We are just asking f of x equals to mod x, is it continuous? Okay, and we have already said that f of x is continuous at x equals to 0. Okay, now we consider c. C is any real number, and we have to take the continuity of f at x equals to c. Okay, and see that when c less than 0, when c less than 0, that means when c is negative, then f of c will be what? This is minus c. Is that it? When c less than 0, it is what? F of x equals to minus c. From the definition, we can easily find f of x c equals to minus c, because when x less than 0, it is what? Minus x. We consider c less than 0, so f of c will be what? Minus c. And here also we consider x c less than 0. So we consider the lateral limit. So limit x tends to c minus f of x is also what? Minus. Okay. Is it clear? Because for x equals to 0, it is already set. Now we have to set the positive for the positive value and the negative value. For the negative value, it will be what? C less than 0, and the positive part we have to set for c greater than 0. Okay. For x equals to 0, it has already set. Now you have to set for c less than 0, that means for negative value, and you also have to set for x, c greater than 0, that means for the positive value you have also be set. Okay. Now see that we consider c less than 0. That means what? C is negative. C is negative real number. Okay. C less than 0 means what? C is considered as a real number. And if we write c less than 0, that means what? C is negative. So when c is negative, then f of c will be what? Minus c. Okay. Is it clear? Is it clear?
Yes, ma'am.
And for that,
Yes, ma'am.
we consider the left hand limit, that is x tends to c minus f of x, and it will be what? X tends to c minus f of x. Now tell me, it will be what? Because here c less than 0, so it will be also what? Minus x. In the place of f of x, we write it is minus x, is not it? X tends to c f of x. In the place of f of x, we just write minus x, because x tends to c minus, because c is less than 0. So limit x tends to c minus f minus x. So value of this one will be what? Minus c. Okay. Is it clear? Now see that f of c is what? F of c equals to limit x tends to c f of x. Now from this one we can say that f is continuous at all negative real numbers. Okay. F is continuous at all negative real numbers. Now you have to set the continuity of f for all positive real numbers. So for the positive case, we have to consider c greater than 0. Okay, c greater than 0, because we consider c is a positive real number. So c is a positive real number, so it is what? C greater than 0. If we consider c greater than 0, then f of c will be what?
F of c will be c.
Yeah, it is also c. It is positive c, because c greater than 0. So according to the definition, we get f of c is what? Plus c. Is that it? F of c is what? Plus c. And now can you tell me x tends to c, f of x will be what?
Limit tends to
X tends to c, f of x is also what? Limit x tends to c, f of x. Also what?
yes.
Yeah. Yasmin, tell me. When we consider x greater than 0, then x tends to c, f of x will be what?
Limit existence to c, which
Yeah,
plus x,
yeah,
and then
plus x. So value is what? Plus c. Okay. So
c. Yes.
if we consider c is a positive real number, then what we get? Limit x tends to c, f of x equals to f of c. Okay. From all the cases, we have take two cases, and for 0, x equals to 0, it has already set, and from these three cases we say that f of x is continuous. Okay. Okay, so we can say that f is
Okay.
continuous at all real numbers. Okay, for positive real number we have set, and for the negative we consider the negative real number. It satisfies the condition, and for the x equals to 0, it satisfies the definition of the continuity. So from these three cases we can say that f is continuous at all real numbers. Okay. Okay, is it clear?
Yes, ma'am. Yes.
Okay, then now this is an example of polynomial function. See that f of x equals to x cube plus x square minus 1. And I have already told you that polynomial function is continuous everywhere. Okay, write it also as a note. Polynomial function is also continuous everywhere. Modulus function is continuous for all real number, and constant function, identity function, it is also continuous. And next write that polynomial function is continuous everywhere. Here see that f of x is what? X cube plus x square minus 1. This is a polynomial function, is not it? X cube plus x square minus 1. This is a polynomial function, so we can say that it is continuous. Okay? And see that this one f of x equals to 1 by x, and this is what? This is the rational function 1 by x, and here x does not equals to 0. This is the necessary condition. If x does not equals to 0, then we say that this function is also continuous. Here condition is so we can say the rational function is also continuous. Here condition is what? That suppose the function is defined as f of x divided by g of x, and condition is what? If g of x does not equals to 0, then we can say that the function is continuous. Okay, here function is defined as 1 by x, and we are given that x does not equals to 0. This is necessary. This is necessary condition. So we can say that f of x is continuous. Okay. And write this problem, and this is your homework. Discuss the continuity of f defined by induced way. This is your homework for today. F of x equals to defined as x plus 2 if x less equals to 1, and x minus 2 if x greater than 1. Discuss the continuity of the function f, which is defined by f of x equals to x plus 2 if x less equals to 1, and x minus 2 if x greater than 1. Discuss the continuity of the function f, which is defined by f of x equals to x plus 2 if x less equals to 1, and x minus 2 if x greater than 1. Okay? Have you right? And now you have to state the continuity. And for this type of function, you have to state the continuity at x equals to 1. Because in the problem, function is given for the value x less equals to 1 and x greater than 1. Okay, so you have to set the continuity at x equals to 1, and for the other point it is continuous. And now you have to set the continuity for x equals to 1. For the other point it is what? X plus 2 and f minus 2. These are what? These are polynomial function, and we have already said that polynomial function is continuous everywhere. So for the other points, for the function is continuous, but you have to set the continuity for x equals to 1. Okay, because in the problem function is defined for the value x less equals to 1 and x greater than 1. Okay, now you have to set the continuity at x equals to 1. Okay, and this is your homework. Okay, have you write the problem, students? Hello,
Yes.
have you write the problem?
Yes, ma'am.
Okay, then try to solve this one. And similarly, write this problem also. Find all the point of discontinuity of the function f, which is defined by this one. X plus 2 if x less than 1. 0 if x equals to 1. X minus 2 if x greater than 1. Find all the point of discontinuity of the function f, which is defined by f of x equals to x plus 2 if x less than 1. 0 if x equals to 1. X minus 2 if x greater than 1. X plus 2 if x less than 1, 0 if x equals to 1, x minus 2 if x greater than 1. Okay, now you have to find all the point of discontinuity. Here also you have to check the continuity at x equals to 1. Okay, because the function is given for strictly x less than 1, x equals to 1 and x greater than strictly greater than 1. So we have to set the point continuity of f at x equals to 1. Okay. Is there any confusion? Is there any confusion regarding this example? Hello? Hello?
Hello, ma'am.
Yeah, is there any doubt?
No, ma'am.
Okay then, for today I stop and give you attendance through the group.